When we picture ancient Egypt, we see pyramids, pharaohs, sand, but we rarely ask a more dangerous question. What kind of machines did they really use? Because the stones of Giza do not move themselves. Granite does not cut itself. Obelisks weighing hundreds of tons do not rise by prayer alone. We are told they used copper tools, ropes, wooden sleds, human labor, and yet the precision carved into diorite and granite rivals modern machining. Drill cores show spiral grooves consistent with advanced rotational pressure. Massive blocks were lifted higher than a 40-story building, and irrigation systems fed millions in a desert. So the real question is not, did they build it? The question is, how advanced was their technology? Hello, everybody, and welcome to Echoes of History, where lost voices of the past finally get to speak. Tonight, we explore the machines of ancient Egypt, not myths, not aliens, but real tools, real engineering, and real mysteries carved into stone. Because once you understand their technology, Egypt stops looking ancient and starts looking intelligent. The Great Pyramid at Giza contains over 2.3 million stone blocks, some weighing over 70 tons. The granite in the King's Chamber came from Aswan, over 800 kilometers away. Let's start with cutting. Egyptians used copper chisels and saws. Copper is soft. Granite is extremely hard. So how did they shape it? Archaeological evidence suggests something fascinating. They used copper saws with sand as an abrasive. Quartz sand is harder than granite. When combined with pressure and motion, it becomes a cutting system. In other words, they created a primitive but effective cutting machine. Drill cores discovered by engineer Flinders Petrie show spiral drill marks. These grooves suggest consistent rotational drilling with downward force. Some researchers argue the feed rate appears surprisingly efficient. But rather than mystery, this may indicate organized, specialized workshops. Now, lifting. How do you raise 70-ton blocks 146 meters high? Several theories exist. Straight ramps, massive but temporary. Spiral ramps, wrapping around the pyramid. Internal ramp systems, discovered through modern scanning. Recent evidence supports internal corridors used during construction, not magic, not lost super tech, but intelligent engineering. Counterweights, levers, rollers, lubricated sleds on wet sand, proven experimentally to reduce friction significantly, which reveals something important. Egypt wasn't primitive, it was optimized. They engineered systems around available materials, stone, wood, rope, water. Simple components, complex results. But construction was only one part of their technological world, because Egypt mastered something even more powerful than stone: water. Egypt should not have supported millions of people. It is surrounded by desert, yet it became one of the longest-lasting civilizations in history. Why? Because they engineered the Nile. The Nile flooded predictably, but floodwaters had to be controlled, redirected, stored. Egyptians built basin irrigation systems, vast networks of levees and channels. They used nilometers, structures designed to measure water levels precisely. This allowed taxation based on predicted crop yield. That is technological governance. Later, they developed the shaduf, a counterweighted lever system used to lift water, simple, elegant, efficient. The shaduf is essentially a mechanical crane for water. Counterbalance weight on one side, bucket on the other. Minimal human energy required. This is mechanical advantage in action. Then came the sakya, a water wheel powered by animals. Continuous rotation, continuous irrigation, continuous agriculture. These were not random inventions. They were systemic technologies. Egyptian temples also incorporated mechanical elements, massive doors pivoting with surprising balance, hidden chambers aligned to solar cycles. At Abu Simbel, sunlight penetrates the sanctuary only twice a year, illuminating statues deep inside. That required astronomical precision, which means their machines were not only physical, they were architectural machines, stone structures designed to interact with the cosmos. And this leads us to something even more intriguing, because some of their devices blur the line between tool and mystery. Let's talk about the so-called Baghdad battery, though Mesopotamian, not Egyptian, often mentioned in alternative theories. But Egypt has its own curiosities. The Dendera light relief, carvings that some interpret as giant light bulbs. Mainstream scholars interpret them as symbolic lotus imagery. But here's what matters. Egypt encoded technology in symbolism. Their writing system blended engineering and spirituality. Now, medicine. The Edwin Smith Papyrus describes surgical procedures, detailed anatomical knowledge, diagnosis, treatment. They understood fractures, sutures, trauma care. Mummification required chemical experimentation. Resins, preservation techniques, antibacterial substances. That is applied chemistry. Their calendar was solar, 365 days, incredibly accurate. They tracked Sirius to predict floods, astronomy as agricultural technology, mathematics as architectural technology, religion as psychological technology. Everything interconnected. Egypt did not separate science from spirituality. It merged them, which may be why modern observers sometimes misinterpret their achievements. We look for steel cranes, electric drills, motors. But Egypt operated on a different principle: leverage, alignment, systems thinking, optimization. They built with physics, not fantasy. And yet, there are still sealed chambers, unopened voids, unexplored tunnels beneath Giza. What tools lie inside them? What inscriptions remain unseen? The greatest Egyptian machine may not have been a device. It may have been their civilization itself, a system engineered to endure thousands of years. And it worked, because we are still studying it, still questioning it, still trying to understand how a civilization so old feels so advanced. Thank you for joining Echoes of History, where lost voices of the past finally get to speak.